Okay, so now I'm coming back with one last video on ellipses because I want to be really complete about this. And so in the previous video, I came up with this idea where I've got a focus that with just 2 points. So one focus is at 1, 2, the other focus is at 5, 8. I just made up points. The center is going to be halfway between those, which is going to be 3, 5. And then I said that my common distance was 10, and so that meant that this distance here was 10, which meant that A was 5, and we sort of came at it from that way. Okay, so now what I want to do is I want to look at things from a different perspective. So what I want to do is rather than this stuff here, this is the messy business that I came up with in the previous video. And I want to look at that from a different perspective. Okay. The line that connects the foci is going to, it has a slope of 3/2, and so you can and a point of, let's call it the point that I want to use, any point will do, but let's use 3, 5. So let's graph that. Y, that should be a comma, by the way. Y minus 5 is equal to 3/2 x minus 3. Okay, good. Now I want to rewrite that as y0 equals negative y plus 5 plus 3/2 x minus 9/2. Okay, got the same line. Now I want to rewrite that as, let's just kill this one out of here. I want to rewrite that as 0 equals negative 2y plus 3x minus or plus 1. So I multiplied everything by 2, and then I did, so I've got 10 minus 9, and so I've got minus 2y. So that's what I want you to look at. And there I've got the same line there. So there I've got that. And now I want to do something else to this line, which is a little bit funky. Is I want to write 0 equals negative 2y plus 3x plus 1 divided by 2 squared plus 3 squared to the 1/2. Okay, so I took this number, I should actually make that so you can see exactly what I'm doing. So there's my new line. And we're almost to the last step of that, where I'm going to say 0 equals negative 2y plus 3x plus 1 all over, that's going to be 4 plus 9, that's going to be square root of 13. And let's make that red. Boom, there you go. Now, if I want to find the line next, find the line that connects, well, that defines the semi-minor axis. Okay, so the slope is going to be equal to the negative reciprocal of 3/2, so negative 2/3 at a point of 3, 5, because it's going to go through that same point. Okay, take that out, and let's start building this again. So I've got y minus 5 equals my point, so it's a negative 2 divided by 3, x minus 3, and sure enough, that gets me where I want to be. And so then I look at that again, still building it, and I go 0 equals negative y plus 5 minus 2/3 x plus 6. Oh, did that wrong. That's going to be plus 2. Sorry, plus 2. Good, so that corrected me. And then I want to multiply everything by 3. So I want to go 0 equals negative 3y plus 15 minus 2x plus 6. Still good. I want to do 0 equals negative 3y plus or minus 2x plus 21. Still good. And now I want to do one last. 0 equals negative 3y minus 2x plus 21, and then I want to take all of that and I want to divide it by the square root of 9 plus 4. So again, that's going to be square root of 9 over square root of 13. So that square root of 13 is still going to show up, and I still got that line. Okay, now in order to get my ellipse, this is where it's really going to sort of all come together. In order to get my ellipse, what I want to do is I want to do this squared divided by 13, which is that squared, times that 25, plus this squared, all that over 13, times, and then my coefficient over there was 12, equals 1, and there's my ellipse. There's my rotated ellipse. So here you can see if I turn it off, there's the original one. That's this messed up equation here. So I take that messed up equation and I turn it off, and then I go back and lost it again. Scroll works a little bit too well sometimes. And I turn that one on, and there we go. And so then one last thing that I can do with this is I can take that equation and, well, let's just do 13 times 25. So let's just, right here, 13 times 25 is 325. So let's replace that by 325. And let's replace that by 156. And let's make it red. And there you go. So there's a second way to calculate an ellipse that has any. So what was the goal? Okay, so I just started off with two random points and a common distance of, in this case, 10. And from that, I built up my ellipse.